In this video, we will explore foundational text-based evaluation models for LLMs, such as METEOR and Perplexity, alongside fairness evaluation metrics. Did you know that biased AI models can negatively impact applications in critical areas like loan approvals and hiring decisions? By using METEOR and Perplexity, you can mitigate the risks of these biases by ensuring your models are both high-performing and fair. By the end of this video, you will understand how different evaluation metrics like METEOR and Perplexity work and why they are important. You will also learn about the significance of fairness metrics in ensuring that AI applications treat all demographic groups equitably. METEOR, or Metric for Evaluation of Translation with Explicit Ordering, improves upon earlier metrics like BLUE by considering synonyms, paraphrasing, and stemming. It assesses translation quality based on literal accuracy, fluency, and intent, making it valuable for applications requiring nuanced language understanding. Let's consider a practical example to understand how METEOR works. Imagine we have two translations of the English phrase, "The quick brown fox jumps over the lazy dog." METEOR would score translation A higher than translation B. Although both translations convey similar meanings, translation A maintains a more accurate and fluent structure with appropriate synonym usage: leaps for jumps and fast for quick. METEOR evaluates these translations by analyzing word order, synonymy, and the overall semantic similarity to the reference text. This emphasizes the translation's fluency and comprehensibility. Perplexity is another measurement used to evaluate language models by assessing how well a model can predict a sample of text. It is based on the probability distribution the model assigns to a sequence of words, with lower values indicating that the model predicts the sequence more accurately. Perplexity essentially quantifies the model's uncertainty about its predictions. It provides a gauge of its effectiveness in language understanding and generation tasks. Let's look at an example. Consider a model tasked with predicting the next word in the sentence, "The cat sat on the..." Suppose our model predicts 4 possible completions: mat, window, car, and moon, with respective probabilities of 0.5, 0.2, 0.2, and 0.1. The perplexity of the model for this prediction can be calculated by taking the inverse of the probability of the correct word, mat in this case, raised to the power of -1. Here, perplexity would be 2, indicating relatively low uncertainty. Lower perplexity values demonstrate the model's confidence and accuracy in its predictions, suggesting a better understanding of the context "the cat sat on the mat." And we also have fairness evaluation metrics, which are critical tools used to assess whether AI models perform equitably across different demographic groups. These metrics help identify biases in model predictions that could disadvantage certain groups based on gender, race, age, or other factors. It can be done by evaluating differences in error rates, positive prediction proportions, and other performance indicators. For example, consider a loan approval AI model that uses personal data to predict creditworthiness. To assess fairness, we could analyze 1. Difference in positive proportions in predicted labels. If 40% of applicants from Group A, for example, male applicants, are predicted as creditworthy compared to only 20% from Group B, in this example, female applicants, this metric would highlight a potential bias in model predictions favoring Group A. 2. Recall difference. If the model identifies 90% of actual creditworthy individuals in Group A, but only 70% in Group B, the recall difference metric would indicate the model is less effective for Group B, potentially leading to unfair treatment. 3. Specificity difference. Examining how well the model avoids false positives across groups, we might find that it incorrectly labels non-creditworthy individuals as creditworthy at different rates between groups, which could affect the fairness of the decision-making process. In conclusion, this video has demonstrated the crucial roles that both performance and fairness evaluation metrics play in the development and deployment of language models. We've seen how metrics like METEOR and Perplexity help ensure that models perform optimally, while fairness metrics address biases to promote equity and trust in AI technologies.